Hello everybody, my name is Julien Casta, I'm CEO at Oncomeca. The main objective of the Oncomeca project is to develop a medical device, allowing a rapid and early diagnosis of skin cancer. This tool will provide support for decision making to general practitioners and occupational health physicians. This medical device relies on the use of the biomechanical properties of tissues for diagnosis purposes, through the identification of new markers, like mechanomarkers in this case, which will enable to characterize and classify the lesion. For each device, we need to realize another database to improve the robustness of the Oncomeca medical device. The strategy is to focus on the signal between captors inside it, and Oncomeca measures the stiffness of the skin by annotation, like that. The force is recorded at each micrometer, and we create, in fact, a force curves annotation. The first strategy of the ELISE project was to validate a contact point, as you can see here, recognition model to fit the curve with a theoretical approach like Earth's models in our case. This contact point is very crucial to extract at the end the mechanical data exactly at the 100 micrometer and unlimitedly increase the accuracy of the lesion prediction. The AI model for this contact point is based on the lesion image tag. To make a prediction, there are two steps. The first step is to take a picture of the lesion with a dermoscope. The second step is to measure the skin stiffness directly on the suspicious lesion and near the lesion. Our program allows to process the mechanical data by recreating the annotation force curve, detecting the contact point thanks to AE, extract mechanics at 100 micrometer, and then to realize a ratio between the two zones of measurement for the mechanical measurements. So the result at the end is obtained is a ratio between the lesion and the wild type zone. The two data are aggreged, picture here, and mechanical, to be uploaded in our web platform to have a prediction with our intelligence artificial. The IA corresponds to the full connected layers allowed to merge the two types of input in a ResNet 550 encoder. And finally, we obtain this graph with a statistical analysis of the lesion and, in this case, the measure of a simple nevus. To summarize, we have developed a new device more accurate to accurate new data to increase database and improve our intelligence artificial. We have developed another AE for contact point detection. We have a functional learning workflow concatenating the two types of data. We need to use a large database acquisition to increase skin cancer detection up to 905%. The regulation affairs are very important in our case to AA validation and authorization by authorities to use this medical device, and the innovation is in development, and the precision of the captors are very, very impressive. We need to continue with a clinical study in October with our hospital partner to test Oncomeca in the medical environment with the gold standard dermatologists, and we will go further in the expandability to improve the architecture and the precision of the AA. Thank you very much.